Okay, we have completed the half of the second module, almost all. Okay, we left with the two more concepts in the second module. Two more concepts in the second module. So that second module we have the another third concept is here, the models and the ports. Whatever we are discussing today, these are the topics comes under the second module of the half of the second module also. And even this based on the for this question, this is the fixed question for the fourth question. For the 10 marks, definitely they will ask in the examination. Direct questions are there. Okay, related to concepts we have the direct questions. For this one we have the 10 marks questions is here. What is the write a model, okay, components of the model, and also define the explain the write a program related to SR latch. You will be asking that. This is the frequently asked question in the examination for the fourth question in the your question paper. Fourth question of the question paper. Just to copy the things whatever I am writing in the. Okay, as you all studied in the previous class, that is the models. Okay, what are the different types of models for writing the program? How many are there? How many are there? Based on the abstraction level, we have the four types of models are there. One is what the gate level or structural model. Gate level or structural model. Second one is what the data flow model. Third one is the behavior model. Fourth one is the switch level or transistor level of model. Yes, sir? Based on the abstraction, we have the different types of models. Okay, switch level or transistor level of. Okay, transistor level. As you all studied this is the based on what the abstraction of what the my programming. Okay, we have the less abstraction in the switch level, zero abstraction in the switch level model. So, okay, gate level model is where we don't have any. We have the directly whatever we see the digital system. That one only we will be calling the each and every. That one we are calling the names of that particular gates as the keyword here. Another one is what the data flow model will have the somewhat abstraction compared to the gate level or structure model, and also behavior model is the heavy. Okay, we have the more abstraction here. We will not bother about the detailed programming here. We will write directly some keywords with the programming. Based on the abstraction, we have the these four different types of models. What is the ports? What is the ports? Ports are nothing but the inputs. Okay, input and outputs. Whatever we have the digital system. No? Each and every digital system have the input ports and even the output ports also. Okay, default we have the inputs and outputs. Explicitly, if you want to mention the some ports which will be used defined, that we will not define. Usually, will not consider such a ports if you regularly. But if you want to define if you want to consider such a ports, you should have to explicitly mention the input and output ports also. Sometimes those to be ports also you will be studying here. Models and the ports. Okay, how to write a program with the help of using the this is the ports and the gate, these different types of modules also. Okay, today we'll see the structure, complete the blueprint of the model here. Just I am writing the blueprint of the model here. Okay, this is the blueprint of the model. This is what the body. Okay, this is the components figure of the. This is what the components of model. Okay, this is the components of the model. Here we will define the this is the body. Okay, this is the model as the model name. Directly I'm writing the caps module, and also module name will be writing here, module name. And also we are defining the some ports. Okay, that's the input and output ports. Ports declarations. Ports declaration. Port declaration. Port declaration. And also we have the in parameters list also. Ports. Okay. Port list. Okay. Port list is there. Port list and port declaration, port declaration, port declaration, that is the optional. This is what the declaring of the ports is the optional. And also we have the parameters. Okay, parameters, this is also one of the optional. This is also optional. This is also optional. If you write the model, or if you use the keyword as the model, that always have the end model also. That has the statement as the end model also. End model statement. End model statement. This is what the this is the initial. Okay, this is the body of the completely the our programming. Whatever the whichever we consider, gate level modular consider madre, or data flow modular consider madre, behavioral modular consider madre. But in our Verilog HDL program, we should have the some standard here. These are the blocks of my Verilog model. These are the what is the components of the Verilog model here. This is the type of, okay, this is the main body header part. This is the what the last part. This is the body we will be defining. This is the very common to all different types of programming here. All four types of programming here. All four types of programming. But the body part will be keep on changing. I am writing the all the four types of the body parts here. Both of you get out. If both of you get out my classroom, I am saying you. Hey Prashant, get out. Get out. Just to go outside. Just to go outside class. Leave the class. Leave the class. Just to get out. None gottilladu. You just to get out my class. Just to go. Hold. ಬರದೆ ಫಸ್ಟ್ ಕ್ಲಾಸ್ ಅದ್ರಾಗ ಬೇರೆ ಈ ನಾಟಕ. ಮತ್ ದಿಮಾಕ್ ಬೇರೆ ಮಾಡೋದು. ಸುಮ್ಮ ಕೂಡ್ತಾರ ಕೂಡ್ರಿಲ್ಲ ಎದ್ವರ್ಬೋದು ಕ್ಲಾಸ್ನಾಗ. ಜಬರ್ದಸ್ತ್ ಏನಿಲ್ಲ ಕೂಡದ. ನಾವೇನ್ ಕರೆದಿಲ್ಲ ನಿಮ್ ಕೂಡ್ಬಾರಿ ಕ್ಲಾಸಿಗೆ ಅಂತ. ನಿಮ್ದು ಕೂಡಗಿತ್ತ ಕೂಡ್ರಿ, ಇಲ್ಲ ಎದ್ವರ್ಬೋದು. ಇಲ್ಲಿ ಬಂದ್ ನಿಂತ ಹೇಳ್ರಿ, ನಿಮ್ಗೂ ಗೊತ್ತಾಗತ್ತೆ ಏನದ ಅಂಬದು. Okay, this is what the body of the body. Okay, whatever the we have the four types of programming here. Whatever the things, just I am writing the declaration of wires. Declaration of, I need to declare the wires also. Declaration of wires and other variables. This is the one part. Okay, this is the one block. Another block is what the we are writing the data flow statements here. If I use the data flow model, data flow type of programming model, then I have to define the data flow statements here. Statements, and also similarly, if I go with the gate level model or behavioral model, those to be also be defined here. Instantiations, you should have to write the behavioral statements here. Always are behavioral statements. Always and initial block. as all behavioral statements and also if you are define the gate level or structure, those to be defined, and also sometimes we will call the another program in my programming. Okay, as I told you, our Verilog HDL supports the hoops concepts, means for the if you are using the inheritance concepts here, you will be calling the another program in my program. Other type second that is the another Verilog program in our Verilog program, that is to be done with the instantiation of lower level models, and also we have the some tasks and functions also will be defining. Okay, in my programming, that is to be defined here the some tasks and functions. Okay, if you ask for the examination, okay, explain the components of the model with the in detail. Okay, if then you should have to write the what is the model is the one of the okay, this is the keyword used to what the collection of what the basic building block of our my Verilog HDL, and also it has the collection of elements here, or blocks here, and also it has the some distinct parts. Okay, distinct parts as shown here as the declaration of the Verilog and data flow statements, and also instantiation of lower level of models, and also behavioral model block, and also task container, and also defining of the model. This is what the model keyword, and also end model is enough. Okay, model, and also model name can be anything here. If I am using the SR latch, there you can use the SR latch. If you are using the half adder, you can use the half adder. If you are using the full adder, if you are writing the program for the full adder, then you can also name the model full adder. Port name can be port list. Port list can be any what the inputs and outputs. Yes, inputs adava, yes outputs adava, you should have to mention. But then the parameters ಮತ್ತು declaration of some other ports. This is what the optional. Compulsory the model name port list inputs outputs. But then body compulsory the mata this is what the end model statement is compulsory. Optional the declaration of the what the ports and also parameters also. This is optional. Ella ಡಿಜಿಟಲ್ ಸಿಸ್ಟಮ್ ನಾಗು ಪ್ಯಾರಾಮೀಟರ್ಸ್ ಇರಲ್ಲ, ಎಲ್ಲ ಸಿಸ್ಟಮ್ ನಾಗು ಪೋರ್ಟ್ ಡಿಕ್ಲರೇಷನ್ ಅವಶ್ಯಕತೆ ಇಲ್ಲ. ಪೋರ್ಟ್ಸ್ ಇನ್ ಡಿಫಾಲ್ಟ್ ಆಗಿ ಬರ್ತಿರ್ತಾವೆ ಇನ್ಪುಟ್ಸ್ ಔಟ್ಪುಟ್ಸ್ ಅಂತ. But sometimes if you necessary to what the different types of ports are there, plug-in purpose, some charger purpose, some power supply inputs and outputs, those to be declared with the help of the what the necessary, if it is necessary. If it's not necessary, just you are writing the program for the simple digital system, then you have to define the model name, port list, and also this is the body, this is the end of the model statement. This is all compulsory to write the program. This is all about the my components of my model here. Okay, take the heading as the models and the ports. Take the heading as the models and the ports. Models. Take the subheading as the models. Take the subheading as the models. A model is the basic building block of in the Verilog HDL. A model is the basic building block in the Verilog HDL. Next point, a model can be an element. A model can be an element or collection of lower level design. Model can be an element or collection of lower level elements lower level elements, lower level elements, lower level design blocks, lower level design blocks. Next point, it describes the functionality of the digital design. Next point, it describes, next point, it describes functionality of digital design system. It describes the functionality of digital design system. Next point, a model in Verilog consists of a model in the Verilog HDL consists of different parts as shown in the figure. You should have to write this figure, copy this figure. First is what the three blocks are here, just in first, second, and also middle one. This is the body part. There are three parts. One is what the header part, this is the last part, and also we have the body part here. In the header part we have to define the module, and also module name is also here, and also port list, port declaration optional, and also parameter is optional here. Similarly, the module is ends with the end module. These two statements are compulsory. The body block is consist of the main so many blocks. Inside this one we can define the declaration of the variables or ports here. Another one is what the data flow statements. Third one is what the block instantiation of the lower level of modules. Fourth one is the always statement. This is used for the writing the program in the Verilog model. And the fifth one is what the task and the functions. Just to copy that figure. Just to copy that figure. I hope you all copied. Barkondi. Okay. A model definition. Take the next point. A model definitions always start with a model definition. A model definition always start with keyword. Always start with a keyword model with the double quote. Model with the double quote akre. Model with the double quote. Model double quote akre. Next one, the model name, port list, the model name, comma, port list, the model name, comma, port list, comma, port declaration and optional parameters must be in a model definition. This is what the block we say it was the model definition. Model definition should contain what the model name, port list, port declaration, and also optional parameters must be in the what the model definition block. Must be in model definition block. Next, port list and the port declarations. Port list and the port declaration are present only if port list and the port declaration are present only if the digital system model as HAS as any ports to interact with the external environment. ಈಗ external environment interact ಆಗಬೇಕಾಗಿತ್ತಂದ್ರ ಅದು that should have the inputs and outputs also. Next point, the 5 components within the module are, the 5 components within the module are, the 5 components within the module are, you write these 5 components. The 5 components within the module are, first one is the variable declaration. First one is the variable declaration. Second one the data flow statements. Second one the data flow statements. Third one is the instantiation of lower modules. Third one is the instantiation of lower modules. Third one is the instantiation of lower modules. Fourth one is the behavioral blocks. Fourth one is the behavioral blocks. And fifth one is tasks or functions. Tasks or functions or task and functions. Okay, whatever that defined these tasks, okay, this can be in any order. Okay, these components can be, next point, these components can be, these 5 components can be in any order. These components can be in any order. Okay, not necessary to write the always. The declaration of the ports are compulsory. Variables is opposite. Okay, the components can be, these components can be in any order and at any place in the module definition. These components can be in any order. These components can be in any order and at any place in the module definition. Next, end module statement. Okay, the end module statement. The end module statement always comes at the end module statement. The end module statement must always come last in a module definition. The end module statement must always come last in a module definition. Last in a module definition. Okay, whatever we studied, this is the what the writing defining of the module. Okay, as I told you that this is the what the writing a program. Okay, model in 4 different ways also. For example, we'll consider the one example here, writing a program. Which one should I consider? You tell the in a digital system. Yav togolna ಹೇಳ್ರಿ. Yav togolna half header togolna, full header togolna, SR latch togolna, yav togolna? Which one should select? Okay, for example, SR latch. I am taking the SR latch. SR latch have the digital components as the 2 NAND gates, as the inputs as the 2 inputs and the 2 outputs are there. Which are those? What is this one? S and the R. Okay, this is what the Q. This is what the Q bar. Okay, this is what the Q and Q bar. Okay, I have the 2 inputs and the 2 outputs here. But we are what this is the SR latch is the what the sequential logic circuit. So we have to feed back output of the first gate. It is to feedback to what the as a input, and also for second AND gate, NAND gate is also feedback to is given as the input, output as the to the input also. This is what we have the memory. It means what it has the memory. It has to remember the output of the first output, and also it has to remember the output of the second gate also. We will feedback to giving this as the inputs also. This is what the figure SR latch. Okay, when we design the digital system with the help of what the logic circuits, logic these blocks. Okay, this is what the NAND gate. This is what the NAND gate. This is what the NAND gate, because of the bubble is here. With the AND gate, with the bubble is the NAND. This is what the N1. This is what then give the name as the N2. N2 also. Okay, give the name as the N2. Okay, then we designed. We designed. I to describe this digital design system with the help of the one programming language that is called the Verilog HDL. I have to write the program related to this digital system with the help of what the Verilog HDL. Describing of my this digital system with the help of what the programming that is we call as the Verilog HDL. What type of program you will write? Whether I have to use this complete full blocks here. Whatever I am writing, complete full blocks. Just I am writing the module and also end statement. End module statements must be there. These two are the compulsory. Okay, end module statement. Okay, this is what the module definition and the end module is done. Okay, I have to give the name. Module with the module name can be anything here. What is this? SR latch. SR latch. What is the module name here? SR latch. I am declaring the SR latch as the module name here. Okay, next input ports. As you said that what are the port list? Port list can be here. What the port list can be here. What are those? Input and the outputs. Inputs and the what are those? Outputs. Which are those input ports here? What are the inputs here? What are the inputs here? Shukumar, how the inputs? How the inputs are? Inputs how the set and the reset bars. Set and the reset bar, and also for output of this first is what the input to the first NAND gate. Output of the second NAND gate is the input as input to the first NAND gate. First NAND gate here. So that I am taking the inputs as what are those inputs here. First I have to define what the outputs here. Which are those inputs here? Output here. What are those? Q and the Q bar. Q bar as the inputs. Outputs. Then the I have to do the inputs also here. Which are those? S bar and R bar. These are the inputs to the my inputs and these two are the inputs. These are the outputs here. Okay, this is all declaring of for the inputs and outputs. Then I have to define the inputs and outputs separately. Declaration of wires and other variables. I have to define here. Okay, that's nothing but the input and output here. What are the inputs here? Which are those? S bar and R bar. S bar and R bar. S bar and R bar. S is nothing but the set. Another one is R is nothing but the reset here. Okay. Output, which are those? Output here the Q and the Q bar. Q and Q bar. Okay, I defined my module name as the SR latch, and also I give the input ports and output ports, and also inputs as the and also output also. I have to write the program. Okay, now the body is declaration comes. Whether I should have to write the data flow module statement, or else I have to go with the behavioral or structural. Which one should I go? Easiest one is what the structural. Structural ಅಂದ್ರೆ ಏನು? Gate level model. ಯಾವುದು ಕಣ್ಣಿಗೆ ಕಾಣುತ್ತೋ ಅದೇ ಗೇಟ್ಸ್ ಯೂಸ್ ಮಾಡಬೇಕು. ಯಾವ ಗೇಟ್ಸ್ ಅಲ್ಲಿ? ಎಷ್ಟವ ಗೇಟ್ಸ್? ಅಲ್ಲಿ? ಎಷ್ಟವ ಗೇಟ್ಸ್? ಎರಡು ಅದಾವ, ಮೂರು ಅದಾವ? ಎರಡು ಅದಾವ. ವಿಚ್ ಆರ್ ದ ಗೇಟ್ ನೇಮ್ಸ್? ಗೇಟ್ ನೇಮ್ಸ್ ಏನವ ಅಲ್ಲಿ? N1 N2. Which what type of gates? NAND gate and AND gate avu? NAND gate. So that I can give the name directly as the NAND gate itself as the keyword here, the NAND N1, NAND N1. So that I have to define the first, I have to mention the output always. You remember NAND gate the output enada? First you get, tell me, first NAND gate the output enada? Q. Okay, just to write the Q is okay. Next inputs enadava? S bar ada. S bar bari S bar. Next input enada? The output of the second NAND gate. Q bar is the input to the another first NAND gate. Idu input, the output enada? Input agutta. So that I have to write the output as the S bar and the inputs. First input, output is the input. Another one is the another output is what the input is your Q bar. Okay, next is what the second NAND gate. Second NAND gate ಯಾವುದು? N2 ಅದ. So that I have to write the NAND N2. I have to define the inputs and outputs for this NAND also. What are those? Output of the second NAND gate is what? The Q bar. Q bar. And the inputs for this NAND gate is what? The R bar. R bar, and the another input is what? The Q is there directly in output of this first NAND gate is the as the input here. So that I have to write the Q as the input here. Okay, this is all about the writing a program for the SR latch in the structural or gate level model. Okay, I designed the digital system of the SR latch as the digital system, and also I described this digital system with the help of for the Verilog HDL in the structural model. Okay, I have to check now, okay, whether I written the design the program system right correctly or not, whether I describe the program my digital system in the programming, whether giving the output or not. I have to send the give the inputs for this combination. How many inputs are there? Those number of combinations I have to give the inputs also. Check the inputs. How it is working? 2 to the power of n number of inputs you have to send here. How many inputs are here? 2 numbers inputs are there. 2 to the power of 2 means how many? I have to give the 4 combinations. 4 combination of inputs. What are those 4 combinations? 0 0 0 1 1 0 1 1. These 4 different set of this set of inputs I have to send. Okay, I have to check the these 4 set of inputs as to do this one. This is to be done. Okay, anyway I can check the inputs only in one combination with the programming. If you want to check my program whether it is working correctly or not, whether it is giving the simulation waveform right or wrong for the input combination 4 setup, I have to go with what the writing a program with the test bench. What is that? Test bench. I should have to write what the test bench now here. Okay. Test bench I have to check my whether program is correctly working or not with the input combinations, with the giving the set of input combinations here. What are those input combinations? 0 0 0 1 1 0 1 1. Okay, I am writing the test bench for this one as the model simulate stimulus of the stimulus. So that I consider here the wires. Okay, wires, and they define the wires. These are the interconnection between the, these are the wires, interconnection between the gate to gate we call the wires. These wires also considered as the outputs here. Okay, the outputs can be running on the wires also. So that usually the register keyword used to define the outputs, but here the register keyword is used for defining the inputs here. Which are the inputs here? The set and the reset here. Yes, and the set and the reset are the two inputs combination here. Two input combination. This is what the earlier in the programming we were using the for the output purpose, but in the test bench, while writing the test bench, we will be using the register keyword used for defining the inputs combination. Inputs here for the inputs. Next is what the wire. Wire is usually will be using for the declaring what the inputs. Declaring the inputs, but in the test bench, while writing the test bench, wires are used to define the declare what the outputs here. Wires are used to declare the outputs. What are the outputs here? The Q and the Q bar here. Q and the Q bar. Q and Q bar. Okay, these are the outputs here. Similarly, the I2 is define. Model always models with the end model. You should remember. Model and ಬರೆದ ತಕ್ಷಣ end model ಬರೆಯಬೇಕಿದು. End model. Okay. I to check. Okay. I to give the this is all. I to give the a model name can be SR latch, which is named as the M1 Q bar. First I have to give the outputs here, the Q bar. Inputs, what are those? S bar and R bar, and this is all about the okay R bar. Even you can also write the this one is the set and the reset also. Okay, this is the set. Okay, this is what the operator which is to define what the inverter type. This is what the inverter bar. Okay, this is the inverter of reset of the bar is nothing but the inverting of the reset also. Okay, and also I have the initial block, and also I have initial. If I use the initial, I have to start with always with what the begin and the end also. Within this block, I am sending the set of inputs here. What are the set of input combinations? Whether it is a set of input combinations, what are those? 0, 0, 0, 1, 1, 0, 1, 1 with the small interval as the 5 milliseconds. Okay, for some generation of the waveform here. Okay, what are those inputs combination as the I am doing it here, the displaying here. What are the display purpose? I can use the dollar display. I can use, and also in order to monitor the input combination, I can use the dollar monitor in order to display the timestamp, because I am taking the 5 milliseconds of timestamp. That one purpose also I can use the dollar time also, dollar time also. That one I am using here the dollar monitor in order to monitor the input and output combinations on the wire monitor as the dollar time as set. Okay, percentage of B. What is the value of the set here? The set is having the value as the 0 or 1. That's what I am sending the percentage B. Percentage B andre enagutte binary value. Enagutte Sharan Basappa? Percentage B ಏನಾಗ್ತದೆ ಹೇಳು? ಗುಂಡೆ ಹಾಕೋದು. ಇಬ್ರು ಗುಂಡೆ ಹಾಕೋರು, ಇಬ್ರು ಕ್ಲಾಸ್ ರೂಮ್ನ ಬಟನ್ ಹಾಕೋರು. Percentage B, what is the B can have the binary value can be 0 or 1. Okay, 0 or 1. That's nothing but the set is having the either 0 or 1. And also reset is also having the values as the reset percentage of B also. And also we have the Q as the output, that is nothing but the Q as the percentage of B also. And also I have the set as the set, reset, and Q as the inputs here, output combinations. And also I can have the set of input combinations here. What are those? 0, 0, 0, 1, 1, 1, 1, 1, 0, whatever it may be. This can be defined within the block as the set as the 0, reset as the 0. Okay, set with the 5 milliseconds hash of for the declaring of the hash of 5 milliseconds, hash of 5 milliseconds, hash of 5 milliseconds. With the interval we should have to mention because I'm giving the timestamp here. Okay, set 0, 0, 0 1 1 0 1 1. Just to write the set equals to 0, reset echo 1, set equals to 1, reset as the 0, set equals to 1, reset equals to 1. This is what the input combination I am sending for the checking my this module. Okay, this is the Verilog module. Okay, this is all writing. This is all about the writing a test bench for the my Verilog module. Okay, what I am doing here, just I am simulating, just I am generating about the waveforms here with the, while giving the input combination as the 0 0 0 1 1 0 1 1 with the small interval of time, that is the 5 milliseconds. Okay, this is all about writing a program and also writing a test bench for the example. Okay, defining of the module also. Just to copy the figure, this program, just to copy the, okay, just to define, okay, writing a test bench. You write the test bench for SR latch. SR latch. Okay, just to define. Okay, in the examination, if you ask for the define the Verilog module with the components of the module, and also explain with an example SR latch. Sometimes in the examination we will give the, this is also fixed question. Okay, this is also fixed question. This is the we will be giving the only the SR latch. What is that? Only you will be giving the SR latch. You should have to write the Verilog model program in the structural model or gate level model. Thereafter you need to write the test bench also. Writing of test bench is very easy compared to this program. Okay, this is one of the frequently asked question in the examination. More frequently asked question. Okay, you should remember compulsory question for the 6 marks or 10 marks. This is a fixed question in the 4th question in your question paper. Okay, we don't have any permutation combination for changing here the thinking. Okay, only L1 L2 level of questions they will be asking in the examination. Don't worry, direct questions, direct concepts are there. There will be direct questions for your examination. Okay, time aita. Okay, give the attendance. Sir will come. Okay, our HOD sir will come. Don't go anywhere. Today's date is what? 6. Prabhudev 63 59 75 88 50 89 re ಮತ್ತೆ 64 104 104 101 78 19 90. Okay, 90 99. Okay, done. Thank you. Okay, I left with only one topic, that is related to this only, and so that next class I will complete the second module also. Next module, in the second module also I will complete in the 1 hour 1 class also.